Why is Voyager 1 sending us mysterious signals? No spacecraft has traveled as far from Earth as NASA's Voyager 1. Since it was launched in 1977 to investigate Jupiter and Saturn, it has spent 45 years exploring space. The probe is investigating truly uncharted territories. More information has been transmitted by the Voyager mission, which is now outside the solar system, than by any other mission. However, the probe started sending signals in the spring of 2022 that stumped NASA engineers. They were distinct from any earlier communications from the spacecraft, which had been out of the heliosphere for more than 10 years. What led to the long-lived probe's strange behavior, and what message was it trying to convey? The story of NASA's Voyager 1 spacecraft serves as a reminder of the world's fascination with the first space missions and its hopes for discovering distant planets in the 1960s and 70s. One of the main goals for the United States was to explore the solar system. In the late 1960s and 1972, the suggestion to send probes to nearby planets was first brought up for assessment. The direction of the high-grain antennas towards Earth is maintained by a 3-axis stable spacecraft that uses a gyroscope or an orientation control system based on astronomical coordinates, according to engineers. Sequencing and control tasks are performed by the Command Computer Subsystem, or CCS. The attitude and articulation control subsystem keeps the antenna pointed at Earth and regulates the orientation of the spacecraft. The S-band command transmission rate is 16 bits per second for uplink communication. The electricity for the X-band transmitter is produced by the 3 radioisotope thermoelectric generators, and the current power levels are approximately 249 watts. The X-band transmitting provides telemetry downlink at a rate of 160 bits per second in the normal mode and 1.4 kilobits per second for replicating high-speed plasma wave data. However, the probes were given the name Voyager after the new mission name, created in 1976, was a remarkable innovation for their time. Launched with a 5-year exploration schedule, the spacecraft was charged with approaching Jupiter and Saturn, capturing and sending pictures of these planets' surrounds. Given that it was impossible to return Voyager 1, NASA converted it into a space messenger. On board the probe are greetings in 55 different languages, pictures of people and locations on Earth, and a variety of music ranging from Beethoven to Chuck Berry's Johnny B. Good. The Voyager mission's 2 spacecraft were launched in the same year, which is interesting because Voyager 1, which left Earth second, was planned to arrive first. When the spacecraft passed close to Jupiter in 1979, it revealed to scientists the first act of the moon Io's volcanoes, as well as the 2 moons Fever and Menace. The first lightning strike observed outside of Earth occurred in Jupiter's atmosphere while the spacecraft was in the ring system. Voyager 1's significant discovery after arriving at Saturn and Titan's moon was the discovery of 3 more moons: Atlas, Prometheus, and Pandora. Titan was the first Earth-like planet with a nitrogen-rich atmosphere where liquid ethane and methane may have existed, according to research. Voyager 1 moved upward from the plane of the planet system after its impact with Saturn in order to leave our solar system at a distance of roughly 4 billion miles. As part of its mission, the spacecraft captured its last images. This unique collection of images, which serves as a portrait of the solar system, shows Venus, Earth, Jupiter, Saturn, Uranus, and Neptune, all positioned around the Sun. In a scattered ray of light, our planet can be seen as a small pale blue dot, which causes scientists to consider how susceptible and delicate it is. In order to save power on this particular day, Voyager 1's camera was turned off. For the purpose to conduct exploration, it could no longer approach any planet. The mission's following history was fortunate and a tribute to the dependability of the spacecraft technology. Voyager 1 carried on operating and transmitting data after the initial 5-year mission had ended, extending its travel into the furthest reaches of space. The Pioneer 10's distance was surpassed by the Voyager 1 probe in 1998. Voyager 1 was the first spacecraft to leave the heliosphere and travel into interstellar space in 2004. Particles move more slowly than the speed of sound during the termination shock. The solar wind made of plasma undergoes many changes here, resulting in heating and increased pressure. Even though interstellar space is significantly less dense and hot, it still has its own pressure. For the spacecraft to cross the heliopause and make the last jump, which is accompanied by severe overloads and a shockwave, the heliosphere compresses, bends, and pushes particles when it comes into contact with this pressure. Unfortunately, during the operation, terrestrial antennas were unable to receive signals from Voyager 1. In 2012, the probe reached the heliopause after 8 years, the region where the separation between solar material and locations where particles from other stars have spread takes place. This region of space was home to a human-made object for the first time. 2013's April brought the discovery of a sound made in space by Voyager 1, a unique sound caused by a solar kernel mass ejection. The wave that reached the probe caused vibrations in its surroundings, which had a new, non-heliospheric density, more than 40 times higher than what was previously measured. The final proof of the spacecraft's entry into a new space for NASA and humanity came in the form of the signal's high-pitched tone. Voyager 1 met solar tsunamis several times throughout the course of the ensuing years of its journey and sent data on them. This aided in the development of fresh solar wind models and the investigation of the relationship between the heliosphere and the interstellar medium. In order to continue the mission in 2017, the mission team successfully started the spacecraft's backup engines. Their dependability was unaffected by the 37-year wait. Finally, in 2021, Voyager 1 entered what NASA calls clean interstellar waters, managing the first ongoing measurement of material density in interstellar space. The frequency of the signals sent by the probe can be used to assess environmental changes. The sound increases with increasing electron density and vice versa. The mission team saw a random decline in signal tone that occasionally neared readings for Earth's atmosphere. But in nearly early 2022, the veteran space traveler encountered a confusing situation in space. It started sending distorted telemetry data without indicating any defects or alarms. This became a puzzle for the team of engineers. The probe and its systems were operating normally, receiving commands from Earth, carrying them out, gathering data, and transmitting it. However, the readings from the spacecraft's additive control and articulation systems were not accurate. The difficulty is that it is exactly the axe that maintains the orientation of the Voyager 1 towards Earth. Allowing communication to be kept, a failure of the axe could have led to the loss of the probe. Axe kept going to work, providing a good level of signal, but provided information on the position of the spacecraft as if generated randomly. A situation in which only basic functions take place and the axis is open for diagnosing devices and software. At the step of the data return had to wait for more than 20 hours. The machinery service life forced NASA to take a philosophical approach to the situation. The press assistance does not report how long the situation of the problem with the location of the Voyager 1 has used to be. Such a mystery is kind of usual at this stage of the mission, explains Suzanne Dodd, project manager for Voyager 1 and Voyager 2 at NASA's Engines Laboratory in Southern California. Both spacecrafts are almost 45 years old, which is much longer than the mission planner predicted. We're also in interstellar space and surroundings with high levels of rays that no spacecraft has flown in before. But I think if there was a way to solve this problem with AXE, our team will come across it. The lost space traveler was taken back under control in August of 2022. The culprit for sending incorrect data was also discovered. The onboard computer, which had stopped working many years ago, was activated and connected to the message transmission chain. It hadn't been working for a long time and was not taken into account by the team. When the engineers suspected that this was the issue, they made the decision with a low level of risk to give the AXE team the instruction to start sending data to the correct working computer. This helped to get back to the transmission of telemetry, and Voyager 1 returned to its place in the NASA spacecraft mission and the motion scheme. Perhaps it received an incorrect command generated by another onboard device. If this is the case, there was a failure somewhere else on the spacecraft. The team keeps on looking for the main problem, but does not see it as an ongoing danger to the health of Voyager 1. We are pleased that telemetry has been restored. Suzanne. We will do a full AXE memory read and look at anything in depth. This will help us identify the problem that caused the telemetry mistakes and conduct further investigations. Today, Voyager 1 continues its journey and sends new data about interstellar space. NASA forecasts that the ship's engines will last at least until 2025. Every spacecraft produces about 4 watts less electrical power annually, reducing the number of systems the generator can support. In an effort to minimize the load, mission engineers have blocked heating systems, prioritizing space exploration. No scientific instruments have been shut down due to the decreased power. The probe keeps going to collect data using its cosmic ray instrument, a plasma instrument, a magnometer, and a low-energy particle charging instrument. The Voyager team is working to ensure that the spacecraft continues to collect unique scientific data for as long as necessary, traveling many more miles before it goes to sleep.